Velan is a global manufacturer of industrial valves with over 1,200 employees and 12 manufacturing plants located in 9 countries around the world. The Velan Universal Steam Trap was introduced for the first time in Canada and the United States in January 1950. In those days, the predominant steam trap technologies were cumbersome, inefficient, and required frequent maintenance. Founder and CEO Mr. A.K. Velan set out to design a steam trap that was suitable for the high pressure and high temperature operating conditions that naval vessels and thermal power plants were being designed around at the time. The operation of this new steam trap was based on the principle of a free-floating and rotating ball valve placed on the downstream side of a stellite valve seat and being actuated by a multi-segment bimetallic element. The result is a steam trap that combines effective condensate drainage with high energy efficiency and long service life. In 2012, Velan introduced the Velan Trap Connector Station, VTCS, to the market. This station is designed to API 602 Class 800 and ASME Class 600 valve requirements. It is the only station on the market that achieves this status. The benefit of this valve product is that it can accept any steam trap manufacturer's 2-bolt connector steam trap, as well as comply with all industrial plants' valve standards. Since trap connector stations are usually fitted on steam and condensate manifolds in the petrochemical industry, Velan decided to begin fabricating them under their current ISO program. This presentation details how Velan obtains the parts, complies with the standards, and assembles and tests through its quality program. Velan is always standing behind their products with the motto, "Quality that lasts." This is why. So let's discuss what is a manifold. It is a piping system that needs to comply with the design of ASME B313. A steam manifold is a device that distributes steam to several users. Typical standards are as follows. Body material shall be carbon steel. Maximum operating pressure for design shall be in compliance with the flange rating on the top of the manifold. Manufacturer shall hydrotest the manifold according to company standards. Maximum operating temperature shall be 800 degrees Fahrenheit. Manifold shall be supplied with a drip trap station to ensure dry steam is supplied to tracing circuits. Manufacturer shall provide manifold painted per standard ... Manifold shall be supplied with mounting brackets. Manifold shall have 1.5 inch or larger steam inlet connection. Manifold shall have 3/4 inch NPT drain connection for condensate removal. Welding to be performed in accordance with company standards. A condensate collection manifold is a device to efficiently gather the condensate from several sources that terminate in close proximity. Typical standards are as follows. Body material shall be carbon steel. Maximum operating pressure for design shall be in compliance with the flange rating on the top of the manifold. Manufacturer shall hydrotest the manifold according to company standards. Manufacturer shall provide manifold painted per standard ... Manifold shall be supplied with mounting brackets. Manifold shall have 1.5 inch or larger connection at the top. Manifold shall have 3/4 inch NPT drain connection that permits complete drainage during maintenance. Manifold shall have internal siphon pipe for even temperature distribution and freeze protection. Welding to be performed in accordance with company standards. Velan chose to fabricate their manifolds. This was in a different direction than other steam products manufacturers who were currently manufacturing forged block manifolds. Let me explain why. After speaking with many customers in the Northern Hemisphere, Velan identified 3 problems with the forged block design: space, capacity, and standards. The forged block steam and condensate manifold had a maximum area inside the block of 1.5-inch diameter. This limits the amount of takeoffs you can utilize in colder climates for steam distribution. It also limits the amount of takeoffs you can utilize on the condensate collection end because the largest siphon tube you can fit into a 1.5-inch diameter body space is 3/4-inch NPS. The forged block designs also incorporated piston valves directly mounted onto the block or on the trap connector station. Piston valves do not meet plant valve specifications for numerous reasons. Because of the following reasons: supply capacity, return capacity, and valve standards, Velan embarked on a program to comply with what they believed the market required. However, they also strive to manufacture their product in the same footprint as the forged block manufacturer. For example, a 12 takeoff Armstrong forged block manifold is the same height as the 12 takeoff Velan fabricated manifold. In order to achieve a finished product, Velan followed the following steps: review the corporate line class specification for service of steam, condensate, boiler feed water. This was done throughout all their end users to create a standard. Design the manifold to ASME B313. Confirm the body material, flange class, and corrosion allowance. Review every piece of equipment needed for the manifold and confirm acceptance to the corporate standard. The Velan steam trap stations are built with globe valves and comply with API 602 Class 800. In order to comply with the client's first choice of steam isolation, Stellite 6 is welded into the seat facing and the mating disc to achieve API trim 5. The Velan gate valves on the steam supply and condensate collection drain are also API 602 Class 800 and trim 5. The body of both manifolds is 3-inch Schedule 80 seamless carbon steel A106B. The siphon tube on the condensate collection manifold is 1.5-inch Schedule 80 seamless carbon steel A106B. The branch piping is also Schedule 80 seamless carbon steel A106B. Because it is welded on both ends, thus eliminates the need for Schedule 160 if it were threaded. The fittings, which include the coupling and T, are Class 3000 socket weld carbon steel A105N in accordance with ASME B1611. The socket-let fittings are Class 3000 carbon steel A105N in accordance with ASME B1611 and MSS SP97. On the condensate collection manifold, the pipe flange is 2-inch 150-pound weld neck raised face carbon steel A105N, Schedule 80 in accordance with ASME B1611. On the steam and condensate manifold, the 3-inch end cap and the 3x2 reducer is Schedule 80 carbon steel in accordance with ASTM A234 grade WPB. Once the parts are selected, the next step is to fabricate by welding everything together. Velan incorporates TIG welding and 2 different weld procedures to complete the manifold. One WPS is for carbon steel to carbon steel materials. The other WPS is for stainless steel to carbon steel materials. After drilling holes in the body of the manifold to accept 12 takeoffs, the welder then welds on 12 3/4-inch socolets to the 3-inch pipe. The welder then attaches 12 3/4-inch branch lines to the sockolets via 12 socket welds. The 3-inch cap is then welded on the bottom of the manifold. A hole is burned in the center of the cap, and a 3/4-inch couplet boss is then welded over the hole. A 3/4-inch branch line is then socket welded to the couplet boss as well as to the 3/4-inch gate valve. This valve has a combination end with socket weld inlet and NPT outlet. The 1.5-inch siphon tube is then welded to the inside of the 2-inch 150-pound weld neck raise face flange. The 2-inch by 3-inch reducer is then welded to the 2-inch 150-pound weld neck raise face flange over the siphon tube. The final 3-inch full penetration weld seals the manifold body. The combination end Velan trap connector stations are then socket welded to the end of each branch line. The inlet side of the Velan trap connector station has 3/4-inch NPT ends. Finally, the identification sign and manifold stand brackets are welded onto the front and back of the manifold. Once the welding is complete, the ITP instructs the team to visually verify all the dimensions and flange finish against the drawing. Once this is all confirmed, the manifold is moved into the non-destructive testing portion of the ITP. Velan does 100% radiograph testing, RT, on all the full penetration welds. This includes 2 images on the 2-inch welds and 3 images on the 3-inch welds. Velan does 100% liquid penetrant, PT, on all full penetration welds. Velan does 100% magnetic particle testing, MPT, on all the fillet welds. This includes the sockolets and socket welds. Finally, Velan does 100% hardness tests on all the full penetration welds. This testing corresponds to the attached weld map. These NDT tests are included in the final document pack and is listed on the EN 10204-3.1 Inspection Test Certificate. The manifold is then sent to the hydro test area. The entire manifold has all its valves put into a closed position, and the assembly is bolted to the test stand and filled with water. It is then hydrostatically tested for 10 minutes at a pressure determined by the flange rating on the manifold. For example, if the flange is 2-inch 150-pound, the test will be run at 430 psig. This test is recorded and included on the EN 10204-3.1 Inspection Test Certificate. Please note, all valves and trap connector stations will have already been hydrostatically tested and recorded per the API 602 Class 800 standard before being welded to the manifold. Those results are also captured in the EN 10204-3.1 Inspection Certificate. The manifold then moves to the painting and coating area. The manifold is degreased and painted to Velan reference document VVI-P-081. This instructs the applicator to apply Intertherm 228. All Velan manifolds are painted with Intertherm 228, an epoxy phenolic resin. After 2 coats, a cross-hatch test is performed. A cross-hatch or cross-cut adhesion test is a method used to evaluate the adhesion of a paint or coating to its substrate. It involves cutting a grid pattern into the coating, typically with a specialized tool, and then assessing how well the coating adheres to the substrate after the cuts and the application of pressure-sensitive tape. The attached report is included with the MTR documentation. In terms of compliance and quality, Velan manifolds are designed to ASME B313 standards, ensuring compliance with rigorous safety and engineering requirements across North America. The gate valves and trap connector stations are designed and manufactured to the API 602 Class 800 standard. This adherence underscores Velan's commitment to quality and safety in industrial steam systems. To conclude, I would like you to remember a few things about Velan steam and condensate manifolds. Fully constructed in accordance with ASME B31.3. Internal siphon tube to eliminate water hammer and prevent freezing on all condensate manifolds. All valving is compliant with API 602 Class 800. Coated with Intertherm 228 epoxy phenolic coating. NDE 100% RT, PT, MPT. Improved plant safety. All units provided with material test reports per EN 10204-3.1. Velan is the only manufacturer that provides stock manifolds to this level of compliance. This is the reason our motto is quality that lasts. Thank you.